Well, I wanted to share with you, I'm in the middle of setting up my smoke system, and I'm running my power to the smoke from my triplet PS305, which is a regulated DC power supply. I can adjust this very finely, amps and volts, from 5 amps to 30 volts and down. And what I do is I adjusted it around 8.5, something I think is realistic for this smoke sensor based on my experience. And then I'm able to set it up and watch the temperature. As you can see, there's a probe sitting about a millimeter away from the heater surface, and that's going over to this temperature sensor on this meter, and it's at 31 degrees C right now. The second probe that I have here is hooked up to that meter, and it's showing 26 degrees, but it was down in here. It had moved. It's down inside the heatsink of the controller chip for the smoke unit because he can get hot too. We need to monitor the operating temperature of the devices. I have a resistor that goes into this slot, but what I've done is I've put a variable resistor in, and I can adjust it while everything is running. So when I turn on power, this coil starts to get warm, and it shows me the temperature. It was almost up to 200 a little earlier, but I like to keep it around 110 to 130, something like that, a range. And I allow it to get to a steady state, whereas the hottest it would get and stay. And then I blow on it, and that lowers the temperature, and it also is sensed by the little nudgy thing. I don't know if you can see. I'll try to smooth this in. Do you see that little dude underneath the glass looking thing with 2 leads in the middle there? That is a temperature sensor of the coils, and it's measuring the temperature, and we're using that for a calculation inside this fellow to adjust the voltage. In addition to this manual adjuster, this is an automatic adjuster here, and we'll adjust the voltage. So when it reaches its maximum, I don't want it to get any hotter temperature, then I know what I have to do is do something with this fellow or do something with the variable supply coming inside, drop it something. So I set it up and I'm running it, and I've got it to where it's working. I'm getting information. What I need to do is log the information, change settings, log the information, and create a pattern of operation. Once it saturates, let's say it's sitting at 120, and I got all the numbers where it's at. It's 120 degrees. Then I blow on it, and I can drop it down to 70 degrees just by blowing on it. And that's the temperature of the heater, which is going to be reflected in the sensor. Is going to say, he's getting cold, I need to change my resistance, and that, calculated with this guy, changes the amount of energy going into the heater. And it actually reduces its voltage, and then it reduces its resistance, and then the temperature, the more energy goes into the heater, so it starts to get hotter. So I blow on it, and then I have this as a voltmeter, and I'm watching the volts to the heater. And I can sit here and see it went from 5 volts to 6 volts when I blow on it, which is exactly what it's supposed to do because we've reduced the resistance coming in. Now the challenge is I need to balance the fixed resistor amount. It can't be 0 and it can't be 500. It needs something in between to balance the conditions that I need to maintain smoke, all right? Maintain this temperature to create smoke. I can create smoke about 110, but after you get down to 100 degrees, you start losing the smoke. And that's because this is at 1 millimeter. The smoke and oil and all that pulls heat away, so it needs to be a little hotter. So it needs to be in the 120 to 130 range to really smoke. Now, if we're going full speed, you're going to start getting more airflow through the motor blowing air in. So if you're puffing at a faster rate, you're going to be getting more airflow, and that's going to maintain that cool temperature. And if it maintains the cool temperature, then that's going to tell the chip to give me more heat. Then the variable here is the limiting factor, because we can take this thing down and it says pour the coals to it, or pouring the coals to it, and I'm still not getting enough smoke. Then I have to adjust this guy, or I have to increase the power coming in. The problem with creating the power coming in, increasing that, is if as I go slower and I don't need the heat, I want to dissipate the heat, he throttles it back. He throttles the voltage back. But when he does that, he does it through heat. So this guy starts to get warm. We don't really want this guy to be 140 degrees, 100 deals with it. I got the heat sink on it to help too. There's no fan in this area, so there's just the whirling of the motor. So that's all part of the setup process for me to get this thing to stay steady smoke at low speed and robust smoke at high speed of the engine, because we're going faster and puffing more frequently and creating more airflow. But anyway, that's the setup. That's what I'm going to be messing with. I got to go to lunch now. And I've set this up. Now, the other thing I'm going to show you, and I'm going to try to do this without making everybody seasick, okay? I'm going to stand up, and I'm just going to walk over to my printer. No, I'm not. I'm going to lie. I'm going to turn off my music. Not everybody likes what I like. And show you in a minute the new cam. Well, there it is. This is the old cam with two big lobes, and you can see how wide that dwell was. Here you can see it's much narrower, okay? And I'm hoping I'll still get smooth action. Oh, sorry. I'll still get smooth action, but I'll get on, off, boom, brake, fire, brake, fire, puff, stop, puff, stop. So I'm hoping I'll get a distinct puff now instead of a puff and then a very short break and then a puff again. So we weren't getting a big, how would you call it, delineation, difference, a puff of smoke and then a dead zone, no smoke, like clear chuff, puff thing. Okay, I'm going to try to use this one. So that's the part. There's the design. That's what we call sliced. It's ready for print. It's been sliced into layers, and all those instructions have been created in computer words, and voila, there's our new part. It's been off for a while, so it just releases. So now I got to clean this up, make sure there's no burrs. I got to clean those out so all the screws and everything can fit in there right, the bearings and whatnot. Got to check the surfaces out, make sure they're smooth. The gear teeth look really nice, don't they? And then stick it in there, adjust the cam adjust the limit switch for these cams, and make sure they're touching and free, and they go on and off freely, nice and smooth. Then we can test if this dwell improves the puff and chuff look and feel when we're at speed. That's what I wanted to get to. So I designed this part first thing when I came down, and then I sent it to the printer. And while it was printing, that's when I went over here and rooted around and found all the parts I needed to complete this new smoke control board. And I've just been setting up my test equipment and getting organized. I've done this a lot, and so I know how to do it, and I know what to look for, and I'm ready to dial this baby in. What I'll do is I'll dial in the voltage, max voltage, and I can adjust it on my, look, I put the lid on last night. It fit beautifully, frankly. It fit really good. Okay, so anyway, inside there's the voltage regulator that we adjust, and then I dial this in, and once I get this and I have it where I want it, I measure the resistance that this is set at, and I have the opportunity to put in a fixed resistor that is more robust. These guys are not, they can wear out, they can get overheated, they lose contact. Once I got it dialed, I know where I want it, I put in a fixed resistor. It's a resistor, like this, like one of these, physical thing, the blue thing or the brown thing. I'll put one of those in at the value that I think is the proper maintaining thing, okay? And I'll probably put it in like I have this now, just sort of stuck in, and test it again and see if everything works the way it should. Then I'll assemble it, test it again. If it works that way I want it, with this in and smoke comes out and all that stuff, then I'll take it off and solder the resistor in, because then I'll know what I'll get. Once it's together, you can't adjust it very well. It's kind of fixed. Okay. Everything. Oh, and then the next thing I'm going to have to address is this design for this gizmo, whatever this is. I need to make it better. It's too clunky and big. And then this thing is still not quite right. It's still off. But I'm using it because I just couldn't wait. I couldn't sit there and do that for 3 days, But at any rate, I'm going to come back from lunch. I'm going to put this on, and I'm going to set up this test and get my logbook out and gather some data. And so this afternoon will be tweaking and tuning kind of stuff. And I'm hoping by the end of the day I have it all back together and it's puffing and chuffing better, and it's still got the chuff noise, you still got the puff and the brake and the idle, all that stuff is still going on, and that would be great. And then the two things left would be this guy and this guy. Okay, so I made a mod to the cam, and I'm making a new lid, and I'm tuning the new lid up. That's it. Later, gang. We're going to go for lunch now.